Good morning, ladies and gentlemen. Today we are going to talk about user-defined Java classes. Up to now, we have been using classes which are already defined in the application programming interface. We have used the classes like the scanner class, which is defined in the java.util package. We have used classes like the input stream reader and buffered reader. These two classes are defined in a package which is called java.io. We have used several other classes, right? And we were simply importing the classes and then using the methods which are defined in each of these classes that we have covered. But if you look at the methods which are defined in each of the classes in the application programming interface, these methods, they do not solve each and every problem that we might come across. They have been defined in such a way that they solve certain problems, and there are other problems which they do not solve. For example, if you look at the buffered reader class, if you look at the input stream reader class, the scanner class, these classes were designed to help users to write programs which actually read input through the keyboard, right? And we have got other classes like local date, local time, local date time. These classes were designed to assist programmers to write programs which manipulate dates or date objects. But how about if we are faced with a scenario or a situation wherein we want to manipulate, for example, student objects, wherein maybe we want to manipulate employee objects, wherein maybe we want to manipulate bank account objects, wherein maybe we want to manipulate library objects, wherein we want to manipulate various other objects. There are no methods which can manipulate each and every object in the application programming interface. This then leaves us without an option but to design our own classes, and then we provide methods which allow us to manipulate the various objects that we might be interested in manipulating. So before we actually look at the implementation of our first user-defined class, it is important for us to just define certain concepts. And the concepts that we would want to define, they include class and object. By definition, a class is basically a syntactic unit which encapsulates state and behavior. But this state and behavior is the state and behavior of an object. And an object is actually created from a class. So a class is basically a generic template from which specific instances, which we are referring to as objects, are created. Right, so each and every object has state and behavior. By state, we mean the attributes of that particular object. And by behavior, we mean the functions of that. Right. So in this lecture, we are going to look at modeling employee objects. We are going to look at a scenario wherein we consider the state of an employee object and then the behavior of an employee object. Right? So we are basically going to maybe start with a very, very simple scenario of an employee, and this employee has two attributes, a name and a salary. Right? And then the employee object can perform some functions, and some of these functions, they include maybe get salary, which is basically a function that returns the salary of an employee object. And then we might also want to add functionality such as get name, which returns the name of an employee object. In addition to that, we might also want functionality or a function or a method which allow us to increase or raise or change the salary of an employee. Right? So before we actually do the implementation, let us come up with a class diagram given this information about the employee that we would want to model. Right? So I'm basically going to use a word processing package to come up with a class diagram. Right? So the class that we would want to model, we shall call it employee. And I have already indicated that this class is state and behavior. Right? And state refers to attributes. The attributes are name and salary, and then the behavior or methods, they include maybe get name, get salary, change salary. And in addition to that, we are going to add what are called constructors. Right? So let me quickly draw the class diagram. Right, so in the top section, I write the name of the class, or specify the name of the class. Then this is followed by the attributes of an employee. Right, we said we have got two attributes, which are basically name and what, and salary. So for us to come up with a complete class diagram, we need to know the visibility or the scope of each of these attributes. Right? So we are going to give the attributes private scope, which means that they will only be visible from the class that we have defined. We can't access them outside the class. Right? So if we want to indicate or show that a method, a class, or a variable is a private visibility, we just use the minus symbol. Then after that, we specify the name of an attribute. which is a name here, which is that is the name of an employee. Then after that, we specify the data type. What is the most appropriate data type for a name of an employee? We can use string or string buffer, right? Then after that, we need to specify the next attribute, which is salary. Again, we are going to give it a private scope, right? And the most appropriate data type is double or even float, right? Then after that, we need to specify the behavior of an employee object. What are some of the methods, right? As I have already indicated, one of the methods is a method which retains the name of an employee. Then the other one is a method which retains the salary of an employee. Then we have got a method which changes the salary of an employee. And we also need what are called constructors, right? So let me quickly add these methods. Again, we need to specify the scope first of each method. Then we specify the method name. Then we specify what are called formal parameter types. Then after that, we need to specify the return type of each and every method. That is the type of data or the type of value which will be returned when the program is called, and when it finishes execution and returns to the calling program. What is the type of data, or what is the type of result that it returns to the calling program, right? So since we want to be able to access these methods outside the employee class, we are going to give them public scope. So the symbol that is used is plus to indicate that a method, a class, a variable has public scope, right? Then we specify the name of the method. I'm going to call the method getName, right? Then what are the arguments or parameters that it takes? This method does not take any arguments or parameters. Then what is the return type or type of data that is returned by the function? It returns a string, that is the name. It returns a string. Then let me quickly do the same for the other methods. We have getSalary, right? It doesn't take any arguments. It returns a double, which is the salary. Then we have got the change salary, right? This method is supposed to take one argument, which is basically the new salary, or it could be maybe a percentage increment. It depends with how you want to define the method, because you can maybe just replace the current salary with a new salary. That might be one approach. Then you might maybe pass a percentage increment as an argument. Then you effect that percentage increment to the current salary. So what I'm going to do here is I'm going to define a double argument, right, which will be the new salary. Then what type of data does it return? Here we are simply changing the salary, so we are not going to return any value. So if we are not returning any value, we use the keyword void to indicate that our function does not return any value, right? Then we also need what are called constructors. I will talk about what these constructors are, but they are basically special types of methods with the same name as the name of the class. Our class is called employee, so we also need to define a constructor method with the same name as the name of the class, right? But unlike methods, these constructors, they don't return any value. They don't return any value, and even void, as maybe the return type is not specified when you are defining constructors, right? So you can actually overload constructors, which basically means that you can define constructors with the same name but different argument lists. This constructor, it doesn't take any arguments. You can actually define another one which can take maybe the name and what? The name and salary. So here you just put string and what, and double. Again, it doesn't return any value, right? So I think we are done with the employee class. Like I said, we just want to keep this class definition very, very simple. We are going to add more methods with time, and also more attributes, right? The way that we would want to define our classes is such that we follow what the designers of languages are doing. If you go to the application programming interface and then maybe check the implementation of classes which are in the application programming interface, you realize that none of the classes in the application programming interface has a main method, right? So we are going to follow that approach. We are not going to add the main method in our class definitions or implementations. What we are trying to do is we are trying to separate the implementation of the methods and their access or their interface or their use, right? So if you recall, when we were using methods which are defined in classes which are in the application programming interface, we were simply calling the methods. We were not concerned or worried about how these methods are actually defined in the application programming interface, and we didn't even bother to go and check how these methods are defined. We were simply calling methods like print line so that we actually send some output to the console screen. We were calling methods like read line so that we actually get input through the keyboard. But the implementation was actually hidden in the application programming interface. So that is the strategy that we would want to follow. We want to define a class, then we hide the implementation from the user, and then the user will interact with the implementation through a public interface, which is basically the name of the method, right? So what this basically means is we need to have another class which is basically going to contain the main method, and this class is known as the main class. This is the class which is going to be having the main method, right? And I used a particular convention to name such a class which will be containing the main method. And the convention is that I use this name, and then I just add a suffix test. Other authors, they use a suffix of driver. So you can end up having employee test or employee driver. So I'm going to quickly create that class here, right? So this class is basically going to contain the main method only, right? So I go to insert, then I add a class here, and this class I'm going to call it employee test. You can also call it employee driver. That is, the class from which we are going to instantiate this employee class, right? And then invoke the methods from this class, right? So this is the name of the class. Then after that, it doesn't have any attributes. Then we skip the middle section, and then we go to the last section, where we simply add one method, which is public, and that method is the main method. The main method, it takes a string of an array of strings, and then it returns void. That's the return type, void. Right, so we are done with our design. We now need to take this design, and then we implement it. We now need to implement the design.